This video is all about the superstring theory. To begin with, let's see what is the fundamental indivisible thing in our universe is. Well, there you can see the nucleus of an atom with electrons spinning around it. As we know, the nucleus is made of neutrons, protons and other hadrons. Physicists discovered that these are further made of tiny particles called quarks. The thing that you are going to see now is the building block of this theory or the universe. Although there is no physical proof for their existence, there is some reason to believe that these quarks have energy in them, more or less like filaments which vibrate. Doesn't they look like strings? By now, you must have understood what the string in the string theory meant. Well, the charge, mass and other properties of these strings depend on the way they vibrate. What exactly is this? Consider this elastic band to be a string that you have seen before. This is just an example. If this string vibrates in this pattern, we might get an atom of Ors gold. But if the same string vibrates in a different pattern, we might even get a polymer of plastic. Let's go further. This is a string, just imagine it to be. Let's vibrate it. Let's see what we can get out of it. Oh, I seem to have got a particle. Well, what can this particle be? It's a graviton. What's graviton? Let's see. A graviton is a massless particle that is believed to carry the gravitational force. Before a few centuries, Newton discovered gravity. Although he knew how to work with gravity, he did not know how gravity worked. This question was solved by Einstein in his relativity. But relativity is based on classical physics, but gravity is a quantum phenomenon. And people were unable to relate relativity with quantum mechanics. But as you see, the string theory provided a quantum theory for gravity. Thus, it is also called as the theory of quantum gravity. Now, if the same string is vibrated in a different pattern, instead of getting a graviton, we might get a photon, which carries light. So simply speaking, we are able to describe all the fundamental forces of nature and even all matter. What do you find here? We are able to find a unifying theory, a single theory that can speak whole about the universe. This is like solving your math using a single formula. Well, this man dreamt of this theory of everything, but he was unable to do it. But string theory has brought it into theoretical reality. It is for this reason that the string theory is called as the candidate for the theory of everything. When mathematicians were solving the equations of string theory, they found something strange. They found that for this string theory to exist, it needs a world of 10 dimensions and not 3. And time obviously is the extra one. Well, we see only 3 dimensions: up, down, right, left, front and back. Then where did these extra dimensions come from? Answer to this question was given by a scientist in the year 1907. He said that maybe the world is made of more than 3 dimensions, but they are so tiny and small that we are unable to see them. Well, let's see his idea. Well, this is just a pencil. I am very close to it, and you can notice the thickness of this pencil from this far, and if you are tiny enough, you can even walk on it. But what if I move farther from it? From a farther distance, it seems to be that the pencil is almost one-dimensional. It actually has got thickness, but we are unable to notice it as it is comparatively small. It happens many a times that we could not notice the circumference of scrolled-up bodies. So maybe the tiny dimensions are in the minutest of the minutest part of the world with scrolled-up shape. Maybe like this. There is another shape, but let us not consider with that. Well, this seems to make sense, right? Well, this is all with the string theory. One day I hope that this will be proved, because it's always nice to have a theory of everything. Hope you enjoyed. Thank you.